Okay, first of all, thank you everyone for coming and braving the wonderful Zurich weather. Just quick introduction. So I'm Lloyd, I'm a developer here at IXT. There's Nana sitting in the corner there. She's an intern here. We also have a few other interactive people, Kirsten here, Chris at the back, Kayla, Ira. And Benji is in the cloud. You'll hear his voice from time to time. Just like before we jump into the talk, just some quick housekeeping. So for confidentiality stuff, like our clients' work are on screens and walls and things like that. So please don't take pictures of anything that looks too suspicious. Feel free to take pictures of the talk though and post them on social media. If you have any like concerns or you're not sure, just ask me, like I can approve or disapprove. Code of conduct stuff, just be nice, play fair. If there's an issue, come find me. For internet, there's a QR code on the wall there. Feel free to join our guest Wi-Fi. Bathrooms, just through that door, there's mostly sitting first left and mostly standing second left, or right first right and second right. Yep. Agenda, so we're going to have like the talk now for about an hour. Then there'll be kind of like an apéro afterwards, and like any like Q&A sort of things. And I will kind of like start shooing people out the door around 7, but feel free to like hang out, socialize, make friends. Yes. Before we jump into tonight's speaker though, just a quick announcement for the next one. So we have our next meetup, which is going to be on June 10th with Susan Bleich on visualization of applied research, where she's a professor of geovisualization and visual research, and she'll be kind of explaining how data visualization works in research. But for tonight we're going to be learning about generative data design. We have Christian Schneider here, who's a lecturer at Lucerne Applied Sciences and Arts and Bern Fachhochschule. He's a scientist, a researcher, and an artist, so he's going to be kind of bridging the gap between creativity and analytics. I'm not going to step too much on what he's about to say, so I hand it over to you. Thanks.
Okay, I'm going to be talking about generative data design as a method, but also there's a course called Generative Data Design at the University of Arts in Bern, and I will a little bit talk about that as well. So what is generative data design? Basically, it's creative coding applied to data visualization. I'm going to talk a little bit about definitions and all that in the beginning, show some examples, what I understand under generative data design, and then in the second part of the lecture, we will do some hands-on programming where we program an example. So if you have your laptops here, feel free to join and code with me. Okay. So some words to me. My name is Christian Schneider. I am the co-lead of a course at the University of the Arts in Bern. It's called, it's a Certificate of Advanced Studies, and it's called Certificate of Advanced Studies in Generative Data Design. I also teach at the University of Applied Sciences in Lucerne at the Bachelor of Data Design and Arts. There's some flyers back there if you've seen them. And I also teach at the course of data visualization also at the University of Arts in Bern. And besides that, I'm self-employed. I have some clients, and that's how I earn my money. I originally studied computer science. During my computer science studies, I wasn't really happy what software engineering as a job would be. I also wasn't happy to see what computer scientists do normally, but I was really fascinated what you can do with code, that you can use code as a creative tool. I really loved that. So then after my studies, I went to work at the ETH Zurich at the Department of Architecture, where we worked with urban data for simulations, but also for visualizations. I worked there for about 5 years, and then I worked for the city of Zurich, which was kind of very applied work. And since about 2017, I'm self-employed. So what's this term? Generative data design. Basically, it's a little bit of a wordplay. It comes from generative design. It's a lot about generative design, which is a well-established term, and data design, which is also quite an established term. So what is generative design? Generative design is, if you look at some definitions of generative design, it's an iterative design process. So we have you have one iteration after the other. You use software to generate outputs. This software generates outputs that fulfills maybe some constraints, and then the designer iteratively adjusts the design and for each iteration. So that's kind of a definition of generative design. And when you read further, you could say, okay, by employing computational power to evaluate more design permutations, so you design several design permutation, then a human alone is capable of. So the process is capable of producing some kind of an optimal design that mimics nature's evolutionary approach to design through genetic variation and selection. So you use computing power, you generate different solutions, you generate more solutions than a human alone could do by hand. And then you kind of look at your solutions, you say, okay, this is rubbish, this is what I like, and then you adjust the generation process and try to kind of generate more designs which kind of fulfill your needs. Then that's kind of generative design. I talked about creative coding as well. If you look at definitions of creative coding, you'll get things like creative coding is a process based on exploration, iteration, reflection, and discovery, where code is used as a primary medium to create a wide range of media artifacts. It's kind of similar to the definition of generative design. So I use, in the term of visualization, data visualization, I use these both terms interchangeably. So sometimes I'll talk about creative coding, sometimes I'll talk about generative design. So this was generative design in words. If we want to look at generative design in images, I think this is a really nice book called Generative Design. Many of you might know it. I think this illustrates very nicely what generative design is. So if we look at examples of the website of this book, take one of these examples. So what this sketch here does, it generates a grid of rectangles, and there's a rule set, and the rule says, okay, the distance of each rectangle to the mouse steers the width and the height of the rectangle. And so if I move the mouse, the width and height of the rectangles change accordingly. So this is a nice illustration, for example, of generative design in my eyes. So the idea is you have an idea, you create an abstraction of that idea, you turn it into kind of a rule, like, for example, okay, the distance to the mouse corresponds to the width and height of a rectangle. That could be a rule, or you create an algorithm as an abstraction of your original idea. Then you turn this into source code, so you make some code from this, you run the code on your computer, the computer generates output. And then you look at, as a designer, you look at the output and you say, okay, I like that, I don't like that. Oh, maybe I can modify some things. So maybe you go and modify some parameters in the source code, run the code again, look at the outcode again. Or maybe you're not happy with the rule. You think, I changed the rule or the algorithm, and you change the rule of the algorithm, change the source code, run the code again. And so this loop, you run that in several iterations until you have a design which are you pleased with. So that's kind of the process of generative design in general. So now that we know what generative design is, generative data design, we understand just as generative design somehow related to data. So you could make a generative design which is completely data-driven, for example, or you do some data design and apply some generative methods to this data design. So generative design somehow linked to data. In the course we're offering, the idea is that we use creative coding and apply it to data visualization. So we use creative coding as a design tool. This creates kind of a playful and versatile approach to data exploration and design, with the goal that we create innovative and aesthetically pleasing visualizations. So if we code a data visualization, usually data is already numbers, and then we kind of transform these numbers into positions and shapes and colors of these shapes on the screen through code. So you load the code, you have numbers, you turn them into shapes and colors and positions. That's what we do if you code a data visualization. What you do when you make generative design is your algorithm creates numbers in some way, and you turn these numbers into shapes and colors and positions. So basically, both data visualization and generative design is like painting by numbers with code. So that's basically what it is. So there's a lot of similarities, and if you look at it from a maybe more philosophical, abstract point of view, you could look at data visualization as some kind of subset of generative design. So the small circle being data visualization, the large circle being generative design in general. And by applying, the freedom we have with generative design, what you can do, less thinking about rules of data visualization, we can kind of expand the space of solutions of data visualization. So to create kind of more engaging, maybe more interesting visualizations. That's kind of the basic idea. So how could that look in practice? So if we would have some data of different neighborhoods in Zurich, maybe a straightforward way to display that would be like, for example, a map like this. But now if we take the possibilities of creative coding and apply it to a similar set of data of the neighborhoods of Zurich, maybe it could look something like this. So because my creative coding environment allows me to easily make a 3D environment, so I'll go into 3D, or displaying building footprints is about the same amount of work as displaying neighborhoods of the city of Zurich. We just need a geodata file with the buildings, so I could display the buildings, and then I could, instead of using colors to show the data, I could use a blur effect or a bloom effect on the buildings to kind of represent the data in a way. So this should illustrate a little bit that we can play with the solution space. We could create different solutions with creative coding applied to data. I kind of go with Stefan Sagmeister of Sagmeister and Walsh, which says beauty is also a function. So beauty disappeared in design literature for decades, but it's kind of slowly coming back, and we just like to look at nice things as people. So beauty somehow has a function. It engages people. So if I make something which is nice, people are more likely to look at it, engage with it, and this also applies to data visualization. Here an example of a generative design based on data. The data is not explicitly visible here. So we have a generative design here. The data which is underlying are the building footprints of the city of Zurich. And I could have just displayed the building footprints, so you can see the building footprints. But then instead, you apply here, you apply some methods of creative coding, something like agent simulation, for example, and you think, okay, let's let people walk around in Zurich, and they have a rule, they're not allowed to walk into buildings. And then you let them walk around, you simulate their walking around, and you draw their paths, and that's kind of the output you get, which is visually completely different than if you would draw the building footprints. So here we have creative coding principles applied to data, and this is the output. Or then here as well, we have a data set which underlies this animation. The data set which underlies this animation is public transport data in Zurich. It's tram data. What you see are trams in the city of Zurich, and then the tram data, we know when the trams are moving and when they stop at the stop. And then you could, from a philosophical point of view, say, okay, every time when a tram stops at the station, people go out of the tram and into the tram, so there's an influx and outflux into the area around the tram station. And so a tram station, in a way, it gives an impulse of activity into a neighborhood. And if you take the sum of tram stations and stops of every tram, and you create kind of like a water droplet kind of things, you can see where there's more activity in the city and where there's less activity in the city. And it's visually, it's something completely different than when you just draw dots. Then this is a work of a student of the Bachelor of Data Design and Arts at the University of Applied Sciences in Lucerne. What he did is he had a data set of traffic accidents in the city of Lucerne, and the most straightforward way to display these traffic accidents would be to maybe draw a dot where the accidents occurred. So for every accident, he had the position of the accident and maybe the time of the accident. What was involved, was a car involved or a bicycle involved, and so on. And then the straightforward way would to display dots. But then he said, well, okay, traffic accidents, they usually occur on roads. So why don't I just take like a road data set and combine it with the traffic accident data set? So that's what he did. He looked for each street segment, how many accidents happen on that street segment, and then he displayed the street segment thickness according to the number of accidents, and the transparency would also be steered based on the number of accidents in that segment. And you get a completely different kind of visualization based on that. And you kind of get a feeling which roads are dangerous in Lucerne and which are less dangerous. Or here as well, actually a very simple visualization. What you see here are the restaurants of the city of Zurich. Each restaurant is a dot, but then again, you apply kind of methods of creative coding. So You can apply an algorithm when two dots are very close to each other, they kind of stick together and create together a new kind of dot, like two water drops. When they get close, they merge together and create a larger drop together. And so if you apply something like this, you get this big blob in the middle where there are many restaurants. And it's visually completely different than when you just draw single dots. So that's kind of the idea of generative data design. So if you're interested in coding things like this, so this is all generated in code, there is a course called Generative Data Design. It's a certificate of advanced studies. It takes place at the University of Arts in Bern. The duration is from April to September. Teaching days are Friday and Saturday. The language is German. Yeah, and it takes place on site, usually with a few exceptions where we teach online. And the next session starts in April 2025. Exactly. What kind of technologies do we use to create these visualizations? We use P5.js. Are you familiar with P5.js? Some are, some aren't. P5.js is a JavaScript library for creative coding. It's very well established. The learning curve is quite flat. So it's, in our view, the ideal technologies to do things like that. There are a lot of sources, a lot of tutorials on P5.js. For everything data related, we use D3. Who's familiar with D3? Okay, so for those who don't know, D3 is a JavaScript library for kind of tailor-made, bespoke data visualizations. It's very flexible and very powerful. So for all the stuff, data mining, data manipulation, data mapping, we use D3. Exactly. We will also work a little bit with front-end frameworks. You know, speaking of React or Vue or Svelte, something like that, we will also look a little bit into that, because for some applications, it's just very practical to use front-end frameworks. So during this course, students will also create their own project. The output of this project could be different things. It could be a generative poster, something like that. It could be an interactive web application, something like this. It could be an animation which you generate based on data. Or depending on your skills, it could be a VR application or an augmented reality application or a spatial installation or projections, something like that. Or also, depending on your skills, you could do some 3D printing or CNC milling, something like rapid prototyping, something like that. A word to artificial intelligence. Artificial intelligence, since like one and a half years, artificial intelligence changed the way we code fundamentally. We will use AI tools for coding during the classes. I think there's a big chance in AI where you can just do more as an individual, you can do more complex things. So we will incorporate artificial intelligence in the courses as well. Yeah. So who teaches this course? This is, on the one hand, it's Fabienne Kilcher. She is the founder and partner of a graphic design company agency called Emphase, which is located in Bern and in Lausanne, and by me. So we are the main main kind of lectures in this course. And we also use some, have some experts in data science, which teach things like data manipulation, data mining, stuff like that for the course. And we hope to get some guest lecturers which do interesting things in the field. If you go to the website of the University of Arts of Bern, you'll see that there are 2 certificates of advanced studies which kind of look a little bit similar. There's a certificate of advanced studies in data visualization, and there's the certificate of advanced studies in generative data design. What's the difference? These 2 studies are kind of complementary. So the CAS data visualization focuses on design methodologies for data visualization. So it's about applying systematic methods to data visualization. You learn various techniques and software tools and things like that to create visualizations. There are 2 days of coding as well in this CAS. And the certificate of advanced studies in generative data design is mainly about coding. So it's 19 days of coding. We use creative coding as a design tool, as I mentioned before. There's a great emphasis on creating visualizations through computer programming. So it's a lot about programming, and it's a lot about exploration with data. So that's kind of the difference between these 2 courses. If you're interested in this course, you can contact Fabian Kilcher or me. You can also contact the office directly if you're interested in registering to the course. I've put the link down there. Yeah, that's so much about generative data design by now. Okay, half an hour, that's good. Yeah, next thing would be the exercise. I don't know if you have questions first or if we want to make the questions in the end. Lloyd?
There's one question from online.
Okay.
Benji, do you maybe want to air it?
Sure, happy to do so. So the question from online is if maybe you, Christian, know of any similar course or program that would be in English. So is there another CAS or any other educational program that you know of on generative data design in English?
I don't know by heart, to be honest, but knowing the education systems or the courses in the United States or in England, in English-speaking countries in general, I'm pretty sure that there must be something similar. But I don't know by heart if there is a similar course. I couldn't name one. Maybe you can name one, Benjamin.
Also not from the top of my mind, but I'll quickly go through the links, and if I see something from my references, then I will happily post it in the chat.
Okay. And if you're not German speaking and you're still interested, get in touch with me. Maybe we can work out a solution. Yeah.
So the examples that you showed were very interesting. I would say very much on the artistic side. Do you have an example of where generative data design is uniquely capable to convey information that you would not be able to convey without? Like a practical example that's less on the artistic side, more on the, let's say, informational side of things.
Yeah. Let's see. I would have to, maybe I can show you a video afterwards. I cannot kind of find it right now very, very quickly, but I'll find one afterwards. So what I did once, I worked with some researchers at the university clinic in Regensburg in Germany. And what they did is they gave me like a data set about tinnitus patients, this beeping in the ear syndrome called tinnitus. So they had data of 5,000 patients. The patients, they would kind of register when they have tinnitus. They had an app. They would register, okay, I have tinnitus now. They would register how loud the tinnitus is. They would register their mood. What's my mood, right, in the moment, and so on. So this was a rich data set of about 5,000 patients. And they gave me the data set and said, well, okay, do something with this data. So I visualized this data in a very explorative way, in different ways, similar to what we will do in the exercise just afterwards. And so then from the visualizations, which I showed them, they were like able to gain ideas, for example, from what they want to explore more in the data set. So just by viewing the data, just by seeing the data, it kind of can spark ideas or inspirations to what you want to do, what else you want to do with the visualization. I think there's a lot of potential in visualizing raw data with computational methods like that. Yeah. Any other questions? Okay. Good. So if you have a laptop here, you can code along with me. Otherwise, you can just watch. I will make an exercise.
We put the link to the P5 editor in the meetup description. So if you go to meetup description for today, you'll see it's there.
Yeah, exactly. Or I think if you join the call as well.
Yeah.
It's also.
We've also put it in the chat now.
I just posted it on the chat.
Okay, great. Is anyone having trouble finding the link? Also help. Let's do it with your phone.
Link.
Yeah, I don't.
Let's see. Let me see.
Can you, Benji, can you just post the link again in the chat? Sorry, I don't relate the Zoom.
Check. Might be a job.
So the link in the chat is just the last post for me in the chat.
Last post is the link. Yeah.
Yeah.
And if you open it, it should look like this. And you might want to, so if you want to be able to save what you code, you might want to sign up to this, to the P5 editor. I think otherwise you cannot save what you're coding. You can just run it. Good. Okay. What we will do together is we will take a data set, load it into code, and then visualize the data to kind of, for example, create something like this. So here we had a data set with the restaurants of Zurich, and for each restaurant we have the address or the longitude and latitude of the restaurant, and then we would just display a point for each restaurant, and that's the visualization. So we will do something similar. We will load data and then translate the data into shapes and colors, things like that, just to walk through the process. but we won't do exactly this example. We'll work with another data set. Okay. So what we are doing, the data set we're working with is the following. So we have a data set with penguins. So it looks kind of like this. The data set has 7 columns. So for each penguin, we know the species it belongs to. We know the island which it lives on. We know the bill length. I'll explain what the bill length is if you don't understand. We know the bill depth of a penguin. We know the flipper length. So this is basically the feet. We know the body mass, and we know the sex of each penguin. So this is quite a small data set of about 350 penguins. It's a nice data set because you have a mix of categorical and numerical variables. And it's very suitable for exploratory data analysis, statistical modeling, and machine learning tasks. So this is an example data set which is widely used in these areas. So we will use this data set. So bill length and bill depth is this here. In the penguin, we have the bill length and the bill depth. And the penguins which were observed, they were observed near the Palmer Station, research station in the Antarctica. And we get 3 different species, the chinstrap, the gentoo, and the Adelie pink penguins. And that's how the Palmer Station looks like in real. And these are probably, maybe these are some of the penguins which are in the data set, who knows? Okay, so we will work with this penguin data. Okay, so you can open the link into this P5 picture. There is already some code there, so we don't have to start right from scratch. There's a little bit of code there. I'll explain what is there. I won't be able to explain programming from the very beginning for every one of you. There's just not enough time. I have about 20 minutes left, so. But it should give you an idea of when, you know, how do I load data and how do I turn it into shapes which I can display on the screen. So it should kind of illustrate the process. If you have trouble, if it doesn't display, maybe there are people from interactive things which are here, which could help. Yeah, or otherwise, please just look at the recording afterwards and then kind of like that, try to solve your problems with the code. Because when you code, you always get problems which arise. That's just natural. Okay, what we have here on the left side is the code. And if I press play, the code plays and displays what you coded is displayed in the right side. The code already does something. There's already some code there. What it does is the following. So if you press this little arrow here, you can see some files here. You see an index HTML. This is why, because a P5 project, that's the code we're using here, is a web project, so it uses an index HTML. And then there's the sketch.js file where we put our code. And then there's a penguin.csv file, that's kind of the data file. This is the penguin data. So you see, we have the different columns. So you can think of this as an Excel file in text form. So you have the columns, they are separated with comma. And then, so this is the first line, which kind of names the columns. And then from the second line onwards, you get each row is a penguin. So this penguin belongs to the Adelie species, was observed on the Torgerson Island, has a bill length of 39.1 millimeters, has a bill depth of 18.7 millimeters, and so on. So this is the data which we'll load, and we have around 340 penguins in this data set, which we'll load. What happens here is in a P5 sketch, there's always a setup function. Well, there's usually setup function. What we create there, and usually we have this code here, create canvas, where we say, okay, I create a canvas. That's where I draw onto. And this is the width and this is the height of my canvas. So if I put 400 and 300 here for the width and height, and press play again, you see that the canvas is much smaller. So I choose to have 800 times 560 as the canvas size. There we go. And then this line here is a function of D3. I mentioned D3 in the presentation. This is a function which loads a data file, a CSV file. In our case, it loads the penguins.csv file, and then we store the loaded data in this variable data, which I constructed here. So the code you have already loads the data, and then with console log, we log the data into this area here, into the console. That's how we kind of can observe if the data is really loaded, if some data is in this variable here. And if I press play, I see, okay, there's an array with square brackets. It contains objects. And when I look at this first object here, I see, this is an object, and this object has some properties like the species, the island, the bill length, and so on. And the properties of this object corresponds to the first line in the code. The properties of the second object corresponds to the second line in the data file, and so on. Okay. So we have the data loaded, so now we can visualize it. Okay. Actually, I need my notes. I won't do everything by heart, so I need some notes. So somehow what we will do is the following. I'll tell you what we will do. We will draw circles. So if I put two forward slashes, it means this line is a comment. It will be ignored by P5 when I play it. We will draw circles. So these are like notes for myself. We will draw circles, and the X position of the circle, we will make it depend on the flipper length of the penguin, for example. Yeah. So the X position of the circle will be the flipper length. The Y position, we will take the body mass, and then we will say, okay, and the color of a circle will be driven by the bill length, and the size of the circle, so the diameter, for example, or the radius of the circle, we will make depend, for example, by the bill depth. That's it. So for each penguin, we translate the data in an X position, a Y position, a color, and the size, and we will draw a circle. Okay. And to do that, we need something which kind of is able to translate the flipper length into an X position, the body mass into the Y position, the bill length into a color, the bill depth into a size. So we will create functions to do that. So I will prepare that a little bit. I'll create a variable called xScaled. This we will use later to kind of map the flipper length of a penguin to an X position on the screen. So we can do the same for the Y. So I call it Y scale. We will do the same for the color. So I call that color scale. And we will do the same for the size. I'll call it size scale. Okay. So we want the flipper length to be mapped to an X position of a circle. For that, I kind of have to know what kind of flipper lengths I have in the data. So what's the maximum flipper length? What's the minimum flipper length in the data? We can calculate this automatically. We could go and look in the data, but it's kind of cumbersome. But we can also calculate it. So D3 can help us do that. There's a function in D3 called extent. D3, you can type d3.extent. And then this extent function, it takes an array, our data array here, it takes that as a function argument. And then as a second function argument, you tell the extent functions what you're interested in an object. So we're interested in the flipper length. So you can say, okay, I make D and then I make, this is the so-called arrow function. You make an equal sign and an arrow, and then you write D dot flipper length millimeter. So this part now, this would be usually a point where I start to explain some principles of JavaScript, what this is exactly, but unfortunately, we don't have the time now. Just type it down. This kind of says, okay, for each object, we're interested in the flipper length. And what the extent function will do, it will go through each penguin of the data array, and it will retrieve the flipper length for each penguin. And then in the end, it will give us the minimum and the maximum flipper length. So, and we have to then store this into a variable. So we could say, okay, let flipper length extent, for example, equal D3 extent. And then we could log this into the console to see if something is stored in this variable flipper length extent. And if you've written everything well, there shouldn't be an error message, and you would have a second line in the console having 172 and 231 in an array. So this is the smallest flipper length, and this is the largest flipper length in the data. Now we can use this to create a so-called scale in D3. Scales, I'll explain what scales are just in a moment. So you can write D3 scale linear, and then parentheses open and close, and then dot domain. And then as the domain, you can put the flipper length extent. So this contains the minimum and the maximum flipper length. You can put that inside. And then you write dot range. And you open a square and close a square bracket. And in that, you could say, okay, 0, width. I'll explain in a minute what this does. And then, so this creates a function in the background, which we can store. So we can say x scale equals D3 scale linear, domain flipper length extent range 0 width. So I'll explain right now what this is. So if you're not familiar with D3, what we have is in the data lives in kind of a range. So if you have percentage data, you'll have values between 0 and 100, for example, in the data. And if you want to map these values onto, for example, an X coordinate on the screen, and let's say your canvas is 400 pixels wide, you in a way want to map the value 0 in the data to the value 0 on the screen, and the value 100 in the data you want to map to the value 400 on the screen, for example. So 0 to 100 is called domain in D3, and 0 to 400, 0 to 100 is called domain, and 0 to 400 is called range in D3. And if you've seen here in the code, we said the domain is the flipper length extent, which is 172 to 231, and the range is 0 to width. And width is a variable of P5, which contains the width of my canvas, which contains, in our case, the value 560. So this maps values between 172 and 231 to the range 0 to 560 in our case. So, for example, here, if I would want to create a function which maps from the domain 0 to 100 to the range 0 to 400, you would write D3 scale linear, domain 0 to 100, range 0 to 400. And then if I write my scale of 50, what would the result be? 200, yeah, the result would be 200. Exactly. So scales, they help me to map numbers from the data to the screen. So this is a fundamental part of D3. And now we could go and use, this X scale in the draw function. So what I will do in the draw function, I'll create a for loop. Now, if you would be in my course, I would explain what a for loop is and all that. If some of you probably know what a for loop is, others not. If you don't know it, just type with me. So I make a for loop over the length of the data array. And then what I do, for each of the penguins, I'll calculate the X position. So I say, okay, I create an X variable, and I say the X variable is X scale of data at the position I. That's how I access a specific penguin in the data array. And then from this specific penguin, I'm interested in the flipper length. So the flipper length is like this. So I can write data at the position E dot flipper length. I pass this value to this X scale function, which we created up here. And this will calculate an X position, which is between 0 and the width of my canvas. So let's see if this works. So now I could say, okay, I calculated the X position, and now I could go and create an ellipse at this X position. As Y position, we put 100, and then we can put the width and the height. So the third and the fourth function argument are the width and the height of this ellipse. So I'll put let's put 30, for example, here. So this for loops over all the penguins. For each penguin, it takes the flipper length, calculates an X position based on the flipper length, and then we draw an ellipse on the screen based on the flipper length. And then you should see something on the screen. So these are all the penguins. For each penguin, a circle. Okay. Then we can start to do the same for the Y position. So we could say, okay, we use the body mass to calculate the Y position. So we could here say, okay, I make body mass extent equals D3 extent of data, and say for each penguin, we're interested in the body mass. Okay, and let's log this into the console. See if we don't have any errors. So the body mass extent goes from 2,700 grams to 6,300 grams. So that's the minimal and the maximum body mass we have in the data. And then we can create a Y scale equals D3 scale linear. The domain being body mass extent, and the range we map it to 0 and height. Okay. Now we can use this where we calculated this X, we can also calculate the Y. We can say Y equals Y scale of data I dot mass. Okay. And then this calculates a Y based on the body mass between 0 and height. And we can use this calculated Y as the Y position of the ellipse. And then we already start to see a pattern of the data. So it seems that the flipper length and the body mass are somehow correlate somehow. So the larger the flipper length, the larger the body mass in general. Okay. Now we can do the same for the color scale, similar for the color scale. So we could again create the extent for the bill length. So bill length extent equals D3 extent of data, and then we're interested in bill length. And then we say, okay, we create a color scale and say it's a D3 scale linear. As domain, we use the bill length extent. And now as range, I don't put numbers, but I'll put colors. So I can put, so I'll put colors as a hex code here, for example. So I start with a hashtag and then I type FF0000. This is, this gives us a red, and then I make a comma and I say, okay, 0000FF. So this maps a value for the bill length to the color, to a color between red and blue, between depending on the value of the bill length. Okay, then we can use this color scale down here. I can say, let's see this color scale of data I dot bill length. And then we could say, okay, we set the fill color of the ellipse. So there's a function fill in P5 where we can pass this calculated color and for the ellipse, and then we get colored colored circles. So the red ones are more up here, and there's some blue ones here, but also some bluish ones more down here. So again, we see start to see patterns in the data. And then last, we do something with the build depth, which should drive the size of the ellipse. So we can say build depth extent. So I make like build depth extent equals the 3 extent of data. We're interested in the build, not the build length, but the build depth. And then we can use this to create the size scale. I can say size scale equals D3 scale linear. Dot domain is the build depth extent, and the range is what should we take? Let's say, okay, smallest circle is maybe 0 and the largest circle is maybe 50 in diameter, something like that. Okay, so we can now use this size scale to calculate the size for each penguin. So let S equals size scale of data I dot build depth. And then instead of hard-coded 30 here, I can pass this calculated size based on the data. Oops. Build depth. Build depth. Okay. Let's see. Yeah, that's good. So here we have larger build depths up here, and here we have smaller ones for some reason. So we see an additional pattern in the data. And then maybe I'm a bit, I don't like that things go from the very edge to the very edge all the time. So I would like to add some border. So let's make a variable, call it border, and I'll put it to 200. And instead of mapping the flipper length from 0 to width, I'll map it from the value border to width minus border. Here I map from border to height minus border. And then I play it again. So now everything is kind of more centered in the middle. So these are the basic steps: how you load the data, how you create scales to map the data onto the screen. And here we make a for loop over the data. And for each penguin, we calculate X position, Y position, a color, and the size for an ellipse. And then we set the fill color for the ellipse, and we draw an ellipse for each penguin. These are kind of the steps you would do. So this is one way to visualize this data set. And then we could, for example, if I take a second example here. So in this example here, I'll send you this example. This is a finished example. If we say, okay, the species in the data, so the species, we map to the X value, the sex to the Y value, the island to the color, the bill length to the size, the body mass to some kind of rotation. And then we don't draw circles, but we draw arcs. Then you would get, for example, something like this, which looks completely different as the visualization before. But the principle is exactly the same. You have these scales, you load the data, you create the scales, and you make a for loop over the data and draw a shape for each of the penguins. So that's kind of the... So there are many, many different possibilities to generate solutions. And if we look at how many possibilities there are, so for example, if I would like to draw a circle, like in our example, for each penguin. In the data, we have 7 columns. We have species, island, bill length, bill depth, flipper length, body mass, and sex. As visual variables, so what I want to display, I have the x coordinate, the y coordinate of a circle, the color of the circle, and the size, like the diameter of the circle. If I calculate the number of possibilities without using a column twice, I get 840 different kind of possibilities to visualize the data, just with circles like that. So if I do this by hand, it'll take a long time. I can generate it much faster. Therefore, generative design. If I would draw rectangles and I would map onto the width and the height of the rectangle, I would get 2,520 different possibilities to visualize the data. If I would add a rotation of the rectangle, I would get and map one of the columns to the rotation, I would get 5,040 different representations of the data with this rule. And then if if we enhance the little bit the code we made so that it's able to kind of loop through the different solutions, you'll get different solutions like this. So this has been a little bit of an overview of generative data design. Do you have some questions for this part of the presentation? Yep.
So the idea is that the code that you wrote, that is not generative data design. The code you would write to generate all the possible combinations, or like, for example, let's see what it's like with arcs. Like I would write a function that just passes in a parameter that says, I want arcs, I want circles, and then it would generate all these possible combinations. That would be then the generative part, right?
Well, the code is part of the generative process in a way.
Because to me, as you were writing the code to create the circles, I was thinking, but this is just database. Like, where's the generative part?
Yeah. Well, it's just one part of the generative part. The thing is that I start to write some code like we did, and then I look at the code, and then I go and change some parameters. For example, now I took red and blue as the colors, and I'm like, okay, now I get an overview of the data, but let's change it. Let's take different colors, for example, or let's set different radius, or let's take a different shape. Let's not take a circle, let's take a rectangle. And this process of exploring the data set with different parameters, adapting the code step by step, that's the generative part.
If you do that by hand, like all the possibilities, it's just huge. If you do it by hand, you never are able to explore the possibility space. And if you want to have the best solution, the more easily you can explore all the possibilities, the better result you're going to get.
But to me, what we did was by hand. The not by hand part would be.
The not by hand part would be like
Yeah.
enhancing the code like this. Yeah. Well, that's your homework. Yeah. Of course, what we showed in the exercise is just loading data and then displaying it in a simple way. And then I showed you a second example with the same principle. Then it looked kind of different. And if you would kind of automate it, it would start to look like this. But yeah.
Maybe slightly related to that. So is the point then that, so if you, how far you get from the data, that's basically becomes more like art, like kind of like that it's not so important to just be able to visualize the data, to understand them. I mean, some of these stuff is not understandable,
yeah,
right? So if
yeah.
I want something that it's like, yeah, like the best solution in terms of like how do people understand the penguin
Yeah.
data set? That's more data visualization to me. But then the further you get from there to just something that it, I don't know, looks cool. Or something
Yeah.
like that, then it's
So-
more like art.
So the generative part, it helps you to kind of play the solution space. So, you know, one approach could be to, I look at the data and I think, okay, what do I do with the flipper length? How do I display it? And then you have your data viz skills and all that. And you think, okay, I could map it to the color, for example. And then you maybe make a sketch or something like that. And then you find out by sketching, okay, this kind of looks like it meets my goals, what I want to transmit. Maybe my goal is to show which penguins have the largest flippers, you know? So you try to find a way to visualize the data set to convey that people see which penguins have the largest flippers. That would be kind of a data viz approach, but it's kind of it has a manual aspect to it. You have your strategies in your head and then you try to play them out. And this just helps you to kind of, and this is kind of like we call this kind of a top-down approach, where you get the data set, you look at it, you think, okay, what kind of characteristics does my data set have? And then I try to create rules, how to map the data. And this thing helps you to kind of, we call this more bottom up, where you just don't think too much about the data and just generate solutions. And then from the solutions, you might get ideas from, oh, this is interesting. Oh, I see a pattern here. Let's explore this more, you know? And you would probably say, okay, from these 5,000 solutions, the first 3,000, they're rubbish, you know? And like, but these 100, they look interesting. Maybe I can adjust the algorithm in a way that I can refine what I'm doing with these 100 solutions. It's just a different approach. Yeah.
So I see the value in exploring especially larger data sets. But do you have any kind of best practices or rules how you start? Or do you just do it a bit randomly and see what's coming out? Or do you like take the data and look, okay, if I color every column differently, let's see what comes out. Or if I give it a different shape. How do you approach that?
So I often work with a graphic design studio. And sometimes when we work on projects, what happens is that the graphic designers, they create designs for the data and then they show them to me and then I implement them for like interactive charts or something like that. Okay. But then in other projects, usually projects which come through clients from me, I try to be involved very early in the process, in the design process. And then I use code. I use creative coding as a design method. I start to do things like this, and I show this to the graphic designers, and then they're often like, "Oh, wow, this is interesting." And then maybe they take an idea, and then they refine it with their skills. And this is kind of a different approach how to kind of develop things. This involves using the data right from the beginning. And it's often interesting if you can use raw data and you then see, okay, this is interesting. These are interesting aspects of the data. These are less interesting aspects of the data. Let's leave them away and let's concentrate on that. It just helps you to orient yourself. Yeah.
So okay. Would you say then, because that sounds interesting to me, that from a user aspect of it, or for programmer's aspect to it, one should almost forget everything that one might already kind of knows about the data. For instance, the penguins, now we know that there are 3 species, that they are male and female, and that the flipper length and the buck length is.
Yeah.
So we have some, and we know penguins.
Yeah.
But actually for creating this palette that we then kind of choose which direction that we want to explore more, we actually have to treat the data as if we wouldn't know anything about it now, because otherwise we tend to map the variables that we already consider as differences, for instance, the sex or the species. And then we're like, oh yeah, there's 3 dots, the 3 dots, 3 species, let's see what we can do.
Yeah.
But maybe something completely, so do you consider, to make it very short, do you treat the data as something that you don't know when you work with it?
Yeah, I think there's a value to be a little bit agnostic about the data, and to kind of let yourself be surprised what it shows you. I think that's nice. But I mentioned an example before where I worked with scientists, and they thought they know a lot about their data already because they have their statistical skills and all that. They knew a lot about this tinnitus data about the patients. But then when you would show them visualizations, different kinds of visualizations, they were like, oh, wow, this looks interesting. What kind of pattern is that? And then they were interested, okay, what kind of people are this? And then they discovered, suddenly they discovered new things. And that's kind of the value of being a little bit agnostic about the data and just see what the data shows you. And by just visualizing it in different ways, it's kind of like looking at the data from different perspectives. Some perspectives are just not interesting. Some are maybe interesting. Yeah.
Another small question. Do you also apply any sort of transformations to the data? Because, so, for example, like, I don't know, when you're interested in clustering or things like that, then you would also start doing that kind of stuff, right? So really, or maybe in general, I don't know, you have a super skewed distribution, like, and then it makes sense to transform it to start seeing things that otherwise you couldn't see.
Yeah.
Do you also play around with that? Because that increases in a way even more the combination of things that you could.
Yeah. Well, my data science skills go only so far. So I did projects where I apply clustering, like a K-means cluster or something like that. This can be really interesting to see which penguins are close to each other. In terms of data, this is, for example, very interesting. Or, you could, because you're in the creative coding space, you can do a lot of things. That's the nice thing. And, your knowledge is the limit there. So I personally applied K-means clustering and things like that to data, but then other things I'm not really aware of it. I'm really interested in dimension reduction techniques, for example. So if you have high dimensional data, how do you represent it in a lower dimension so that it makes sense? I'm really interested in that, for example. So I do a lot of experiment in that area. But yeah, I have limited data science knowledge. I'm more kind of computer science / visualization. But yeah, it could be a good approach to everything you know. Yeah.
Did you ever try to throw some data at ChatGPT and tell it, can you visualize this for me? I did this once with immigration data in Zurich. Within seconds, I had really good graphics. Like it wouldn't take so much long.
Yeah.
It is kind of a tool, no? Is it also like for you guys in the course?
Yeah, I shortly mentioned this in one slide. We will use AI tools in the course. I think the AI changed fundamentally how we do programming. Some programmers are afraid that they will lose the jobs. I personally think the more you know yourself, the better you can leverage what ChatGPT does for you. So I think it helps you. You can tackle more complex problem as an individual with AI. Yeah, and it's a great tool for data mining and things like that. Of course, yeah, that's a reality. But it's still, it's a double-edged sword. ChatGPT can also take you down some paths which are dead ends, and you don't know that it's a dead end. It can really be time consuming, but it can help you a lot. Yeah, of course. It's great. I think it's great. Yes. Oh, yes, 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 yes. Yeah. I would reckon I'm 40% faster with AI tools.